Greetings and welcome. We're looking at probability and odds, page 856, the tarea, or homework. And this particular problem, 15, it's talking about selecting one card from a standard deck of 52. Right? Is what they're talking about. So they're saying, what is the probability that it is a black non-face card? Black non-face card. So both of those constraints happening at the same time. First of all, question, how many cards are black in the deck? It'd be 26. Half of the deck is black, the other half is red cards. And then how many well, let's see. Well, how many face cards are there? Well, face cards would be Jack, King, Queen, right? Jack, Queen, King. 12 total. I guess we could say 3 per suit. 6 per color. Maybe. And there's, so non-face cards. Well, there must be 40 total. So there must be 10 per suit. Scroll down too far. And then there must be, nope. Wait a minute. Yeah, and then 20 per color, that's what it is. So in order to answer this question, the probability of black non-face cards, that's what I'm going to be looking for my numerator, right? Non-face. Right? Would be 20 out of the 52 total, and then both of those are divisible by 2. 10 over 26. Oh, I can divide by 2 again. 5/13, and that is the answer. Right? Still think it was worth kind of just writing these down just so you guys get a handle on what's going on with these, making sure you know how that works out. Let's see, problem 25. It says a number cube, a die, all right, is thrown 2 times. Also, it's a cube, so how many sides does it have? 6. All right, so it's not like a 20-sided die because that would be a dodecahedron, not a cube, right? So is thrown 2 times. What is the probability of rolling 2 5s? Now this problem, it's actually beneficial for us to, let's see, have, I'm so clever. It's not a bad idea to actually draw up the sample space. And this is on page 861 of your text. We are not on that page yet, but this usually gives us the best understanding. Drawing up the sample space, I think we did this yesterday with rolling prime numbers or something like that. I don't remember what it was. Maybe it was a kneecap question. So the first cube, or the first roll of the cube and the second roll of the cube is kind of what I'm looking at. So I could roll a 1 then a 1, a 2 then a 1, a 3 then a 1. So what's the probability of rolling 2 5s? Well, one way out of, how many is here total? 36. So the probability is 2 5s is 1 out of 36. Is what I'd be looking at. And using a sample space like this of all possible outcomes is often helpful for us. Kind of just like the kneecap question we just looked at about vans and cars and trucks and colors, right? Same idea. You're able to figure out the possible outcomes and get a handle on the probability a little bit easier. Let's see. Let me ask a follow-up question. What's the probability that the sum is 3? Yeah, if you check this out, probability sum is 3. this diagonal are all of the ones that add up to be 3, right? 1 and 2 or 2 and 1, so this would be 2 out of 36 or 1/18th, right? So I just want to point out you can use this table in a bunch of different ways. Diagonals are kind of the sums that you can find. You can do all sorts of cool stuff. You could say like, what's the probability that you roll at least 1 3 and the sum is greater than 6 or something, you know, like you can come up with all sorts of weird things and narrow it down. But that's the idea of a sample space. That's the easiest way to do that, unless you realize that rolling 2 5s, there was only one way that could happen, and you knew that, well actually, yeah, rolling 2 5s, maybe you could have just done that vanilla way of just saying, well, rolling 1 5 the first time was 1 out of 6, rolling a 5 the second time is 1 out of 6, so 1 out of 36. Because it happened to be kind of a simple case. Where if I asked the question of what's the probability of rolling exactly 1 5, well then you would have had to know this and this, right? And then not included that at all if I said exactly 1 5, because 2 5s would not be exact, right? So that'd be, what's that? 1 2 5 there, 5 there, so that'd be 10 out of 36. Which would reduce. So I just want to point out, right, that's all good stuff. So let's see, last question for us to look at. It says a box contains 1 green, 2 yellow, 3 red marbles. 2 marbles are drawn at random without replacement. All right, so you could just assume you reached into the bag. So let's see. Drawing 2 marbles without replacement is the same as just reaching in the bag and grabbing 2 marbles at the same time. Right. Or you could reach in the bag, grab 1 marble, and then reach in the bag and grab another marble without putting the other one back in. Same sort of setup. All right, won't matter. You'll see them worded both ways, so I just want to make sure you're aware of that. Let's see, which of do you only want me to do 27, 29, or? I don't mind setting up. Want me to just at least set up all of these? Let's set them up. Probability of drawing 2 red. Probability 2 red. Let's see, how many ways could I pick 2 red? Well, that'd be combo 3 2 over, how many marbles were there all together? 6, is that right? So how many ways could I select 6 marbles? Calculate that out and that works out. Let's see, 27. Yeah, I'll just do the setups. Not drawing yellow marbles. So probability 2 not yellow. Let's see, how many not yellow marbles are there? There's 1 green, 3 red, so that's 4 non-yellow marbles. So I'd want to find out how many ways could I select 2 of the not yellows over the total number of ways I could select 2 marbles out of 6. So number of successful ways the event could occur over the total number of ways the event could occur. Question?
You just cancel out the 2 right in that step right now.
Ooh, no, I don't know what that would mean once you did that. Well, let's tell you what. Let's set this one up. So this would have been 4 times 3 times 2 factorial over 4 minus 2 is 2 factorial, and then r is 2 factorial, which I'll just write as 2 times 1. The denominator would have been 6 times 5 times 4 factorial. I'm planning that wisely. 6 minus 2 factorial is 4 factorial, and then r factorial is 2 times 1. So let's see, and so let's see, we'd have 2 times 3 up top is 6, 3 times 5 down bottom is 15. Both of those are divisible by 3, so 2/5. Oh, wait, oh. And that's not the right answer. Let's see. Uh-oh. Wait a minute. Yeah, I divided by 3, right? Yeah. Well, let's see. Not drawing yellow marbles. They're still drawing 2 at random. Oh, guys. They're not asking probability. They're asking odds. So what I want to point out, this is the probability. So the odds, 2 not yellow, well, the success is still 2, right? Odds is success to failure ratio. And the denominator here, 5, all right, S plus F equals total, right? So I want to point out 5 is equal to S plus F. I know what S is. So to solve for F, I could subtract 2 from both sides, and I'd get 3 there. I'm glad we actually investigated these past that. So the same thing here. I'd have to find the probability of failure for the denominator in order to convert that to odds. Yep, so that's one of these ways that problems can be tricky. So that happens. Actually, I wonder if I could set up odds using a combinatoric. Could I figure out the number of ways to fail the event? Let's see, probability 2 red. No, that one actually would be harder to do because failure would include getting at least 1 red or no red. And we'll talk about situations like that a little bit later. So here it's actually easiest just to find the probability. Let's see, let's just do this using straight up calculadora. So combo 3, 2 is 3. 6 combo 2 is 15, so 3/15. So that would reduce to 1/5 is the probability. So the odds would equal 1 over 5 minus 1, or 1 to 4. And that's where the 1/4 comes from. All right, let's look at 28. Drawing 1 green and 1 red. So probability of 1G, 1R. How many green ones were there? There's 1. Red ones, there's 3. So that would be the number of successful ways would be combo 1, 1, selecting 1 from the greens, times the combo 1 from the reds, of which there was 3. Over the total number of ways, there's still 6 total marbles, and I'm selecting 2 of them. I think yesterday some of us put a 1 there in situations like that. So just make sure you're aware of that. So up top, combo 1, 1 is 1, combo 3, 1 is 3, so 1 times 3 is 3. Combo 6, 2, didn't I just calculate that a minute ago at that 15? So 1/5. So the odds are going to be 1 to 4, I believe, again. No, what did I do wrong this time, guys? Man, Mr. Waddy's doing stuff wrong today. Let's see, drawing 1 green and 1 red, right? So 1 green, 1 red, combo. Let's see, wait a minute. Right, combo 3, 1 should be 3. Yeah, and there's definitely 1 green, and there's definitely 6 altogether, right? And 6 combo 2 is 15. And it's definitely using the word and, not or. There's only one way that can happen. This should have taken that into account, I think. But that would double the possible outcomes, and then that would have been 6. Yeah, we'll have to analyze that carefully. But right, because the number of ways I could have arranged the selection of those two, it could have been green and then red, or red and then green. So that's technically a permutation of 2, choose 2, which is 2, I believe, right? Yep. So that's just doubling it. So that would be 6. And then 6/15 would reduce to 2/5. It still wouldn't work out. I don't know. Well, we'll come back to that one. I'm thinking that there's something fishy going on there. Let's see, 29, the probability of drawing two different colors. Oh man, that one's crazy. Also, I want to point out, notice odds does have the potential of being greater than 1 if the ratio of success to failure is more likely than not. Whereas probability was always between 0 and 1. So let's see, probability of drawing two different colors. Let's see. This one is actually a probability question that we would definitely be able to do later on in the chapter, but I don't think they've set you up for knowing how to do that just yet. Well, there's a few situations. That would be the same as probability of 1 green, 1 not green, right? That's one way that it could occur. That could also be the probability of 1, what was it, yellow is one of the colors? What were the 3 colors? Yeah, green, yellow, red. 1 yellow and then 1 not yellow. And the probability of 1 red and 1 not red. Right? That's all of the possible ways you could get 2 different colors for this setup. Does that make sense? And I had to consider all of those possibilities in order to accurately depict it. So the probability of 1 green and 1 not green. How many green were there? There was 1. How many not green were there? There's 5 not green over combo 6-2. Let's see, how many yellow were there? 2. So what's the probability of selecting 1 from the yellow and then 1 from the not yellow? Not yellows, there's a total of 4. Combo 6-2. And then 1 red and 1 not red. Well, red there was 3, right? And not red there would also be 3. Combo 6-2. So theoretically, if I add these all up, now, oh, wait a minute. Guys, there's overlap here. What if this situation, I had 1 yellow and then the 1 not yellow was also green? That number would have been counted twice. Man, that's crazy sauce. So I'd actually have to, oh man. So I hope they don't want you to do like a number tree or of all the outcomes drawing 2 different colors. Because yeah, it would change depending on what was the first color you selected. Yeah, I'll have to come back to 29, guys. Clearly those last 2 I'm not liking. Because I'd have to subtract the probabilities. Man. Yeah, I'd have to subtract all of the overlap in those situations. I can't think of an elegant way to do this. And I don't want to write out all possible combinations, although we could. But that wouldn't be fun. Yeah, I wonder what way they intended you to do this. Well, anyways, internet friends, that'll do for now. We get the basic ideas of probability. This one's kind of a weird one. But we'll talk to you later. Have a good day. Bye-bye.